In 12.1, we began exploring solids. So if you recall from our last chapter, we covered areas of squares and rectangles, rhombuses, triangles, trapezoids, and circles, I believe, and just regular parallelograms as well. So we're going to be utilizing all of those area formulas. For example, a triangle is 1/2 base times height, a circle is pi r squared, and we're also going to be using the circumference for a circle as well, which is 2 pi r. And probably the rectangle and the square are what we're going to use the most. So area equals base times height. Alright, so with solids, instead of just talking about a flat surface area in which we have to paint, instead of just talking about a wall, when we're talking about solids, we're talking about 3D. So we're going to go from 2 dimensions to 3 dimensions. So now we're going to be looking at 3D shapes like cubes, as well as pyramids. If I have a pyramid here, alright, I can have a pyramid, and I can also have cylinders and things like that. So let's look at a couple of classifications. So the first being prism, and the second being a pyramid. Alright, there's a couple of characteristics of both of these, and both are called polyhedrons. So we go from polygons, which the requirements were straight sides, it was closed, and greater than or equal to 3 sides. Right? So that was the requirement for a polygon. Well, if I have a polyhedron, all the sides, all faces are polygons. So I need to know what a polygon is in order to know what a polyhedron is. And the 2 divisions of polyhedron are prism and pyramid. Those are 2 big categories, as well as shapes that don't necessarily go into either of those categories. We would just call those polyhedrons. Alright, so a prism, the main difference is the number of bases between a prism and a pyramid. Prism has 2 bases, and a pyramid only has 1 base. And the special part about the 2 bases is we need to actually look at the prism and see what 2 bases are parallel. They are parallel planes. That meaning if I have the top, the roof of my classroom, the ceiling, and the floor, those are parallel planes. Right? So I could have any sort of shape here, but we can see that this left side and this right side also intersect with the front face. So if I were to determine if it is a prism, I need to see if it has 2 bases that are parallel. So 1, 2, I actually do. And we would name that by blank prism, and that's the shape of the base. So the shape of the base here is a triangle, so this would be a triangular prism. Alright, so a pyramid is going to be named in a similar fashion. It's going to be a blank pyramid, and that's the shape of the base as well. I'm going to type base shape. Okay, so I could have a square pyramid in which the base is actually a square, or I could have a, this one's going to be a little bit more difficult to draw, a hexagonal pyramid, and I only have 1 base, so it's just down here in the bottom. Right? All the other faces are going to be triangles. Right? So all other faces other than the base are triangles. And of a prism, all lateral faces are, let's look at it. What is that lateral face? What is the shape? It's a rectangle. Are rectangles. So those are kind of the things that we're looking for as far as categories go. Now, convex and concave, those are some other categories when referencing polyhedrons or solids, and those are going to look exactly like they did with area, except they're going to be in 3D. So a concave, let's go with concave. A concave shape is going to have a piece that is caving in, except now it is more of a 3D shape. Alright, so I'll expand all those sides. So a 3DL, for example. Alright, and concave was that. And convex, if I actually look at a stop sign, alright, that is what it is going to look like. Alright, so moving on to 12.2. 12.2, we were talking about surface area of prisms and cylinders. Prisms and cylinders. Alright, and I want you to keep in mind that cylinders are not polyhedrons, because they have a curved surface. Alright. So, surface area. The difference between surface area, which our units are still going to be units squared, whatever our unit is, because it is an area. With surface area, it's as if I have a shoebox, or a box of any sort, and I want to paint the outside of the box. Volume would be I want to fill the box with paint, instead of just painting the outside. So it's going to be a different amount. And it's also going to have different units. For area, this is still an area, I'm going to have units squared. So let's look at an example. Now we talked about a net in class, and alright, here is my 3D rectangular prism, because the base is a rectangle. Alright. Alright, I'm going to go ahead and say this is 5 by 2 by 5. It's 5 tall. I'm going to go with that. Okay, so the net of a prism is if I choose to cut it out just of a piece of paper and then fold it up. That is what it would look like. So let me see. I've got a back and a front, and then a left and a right side. Alright, so this is going to be my back and my front and my left and right side. Alright, and then I've also got a top base and a bottom base. I'm just going to put it here with this one. A top and a bottom. This is what a net looks like. Sometimes it's easier to see in area that way. Top and bottom base. Alright, so let's figure out. The surface area is just adding up all of the areas. So looking at the bottom base. It is 2 by 5, so that means it is 10, let's go with centimeters here, centimeters squared. That is what your base 1 is. It just so happens that the top base here, the top base, is going to be the exact same. So I can go ahead and add another 10. Alright, let's look at the right side here. The right side, the dimensions are 2 by 5. I think the most difficult part of this section is actually being able to identify what the dimensions are, just strictly of that rectangle. So I've already got those already taken care of, and now I'm working on these ones. Alright, so if it's 2 by 5 again, it's going to be 10, and the left side is going to have the same dimensions as well, because it's a rectangular prism. So it takes care of those two. Now let's see what we can do with the back. So I'm talking about the back face, and that's going to be the same as the front face. So it is 5 centimeters tall and 5 centimeters wide. So 5 by 5. I'm going to tack on a plus 25 and another plus 25 for the front and back. Alright, so that takes care of all of them. Okay, so if I add all of this up, this gives me 40, and this gives me 50. The total area is 90 centimeters squared. Alright, and that is an example. They have a couple of different formulas that we went over, one of which surface area is equal to 2 times the area of the base, so area of the base, plus, there was an abbreviation, I believe, for lateral area. Alright, so lateral area, what lateral area is talking about are the front, the right side, the back side, and the left side. So the lateral area, it's all of the faces, area of all the faces other than bases, area of lateral faces. Okay, so all of the faces may be different. It just so happens that in this case with the rectangles, they were actually all the same. So another formula that they give you is the surface area is 2 times the bases again, plus the perimeter of the base times the height. And the reason that they give this to you is, let's go ahead and look at a triangular prism here. Alright, here is a triangular prism. If I draw out the net, I'm going to go ahead and, alright, here is my front face. And then I'm going to write the right face there, and the left face there. And then I'm going to go ahead and say the top base is connected there, and the bottom base is connected there. The reason I have the 2 area of the bases, those should be the exact same. That's what a prism is. The bases are the same. So that takes care of this part. Now the next part, the perimeter times the height. Well, here's the height. So if I were to label that, there's the height. And the perimeter of the base looks like this. Perimeter of the base goes around bottom. And that actually becomes, when I lay it out, it becomes the length of this rectangle right there. So really, if I have that height of the solid figure, then I can multiply that by the perimeter of the base, which becomes a length. And so that's going to give me the area of all of those sides together. So that honestly may be an easier way to go about it if you're able to find the perimeter. Alright, on to the last part. So a cylinder. A cylinder. This was the portion that I told you guys to watch the video on. So here's a cylinder. And you guys are going to need to remember that in order to be able to take the surface area, I need to know a formula for the circle. So if I'm thinking of the area of a circle, that is going to be pi r squared, and maybe I need circumference. Circumference is going to be 2 pi r, or we have already discussed this as, pi d. Alright, because 2 radii make up a diameter, so I could just replace the 2r with a d. Okay, so the surface area for a right cylinder, it's going to be the same thing with the 2 bases. It's going to be the same thing with the 2 bases. So surface area, as long as I find the area of the base, which that is what I'm going to be using the pi r squared for, I should be able to find the area of those 2 bases. Now let's take care of this rounded surface here. Alright, if I take care of this rounded surface, how do I find the area? Well, if I draw out my net, here's one base and here's the other base. If I actually unroll a can of soup, if I unroll the label, you will see it is actually a rectangle that is just folded up. Now the question is if I want to take the area, I'm looking at the base and I'm looking at the height of that rectangle. Okay, well, the height is still, the height of the cylinder is going to be the height of that rectangle. Now the question is what is that length? And if I kind of pictorially see it, that is what should line up right there and wrap around the circle. This length should wrap around the circle. So what is that length? That length is the circumference. So in order to find the area, in order to find the shaded area here of this region, I need to have the circumference for that length on bottom. So I need to find 2 pi r. Alright, so this is going to be plus 2 pi rh, 2 pi r, which that's the length, times the height of the cylinder, or you can write 2 times the area of the bases plus the circumference times the height. Alright, in order to find the area and the circumference, I'm going to need to know pi. So let's look at an actual example. Alright, let's go ahead and look at this hockey puck example. So in order to figure out the total surface area, I'm going to need to know the area of the base, which the base is circular, so I'm going to need pi r squared. So I'm definitely going to need to know what the radius is. And then I'm going to need to know the circumference times the height. And in order to know circumference, that is 2 pi r, so I still need to know the radius. Alright, so what is the radius? The radius is 3. Okay, so in order to find the area of one base, pi r squared, I replace the r with the 3, so that becomes 3 squared, which is 9 pi. I'm just going to leave it in terms of pi. So the area of one base is 9 pi, so plugging into my formula, 2 times 9 pi. Alright, plus, what is the circumference? Alright, the circumference, I still need my c equals 2 pi r, and the radius is 3, so that means that the circumference is 6r. So I'm going to have 6r, and what is the height? 1. The 1 is the height of the cylinder. So let's see here. That's going to give me my total surface area in inches squared. Alright? Inches squared. Oops, sorry. Should be a 6 pi. 6 pi. Alright. So this is 18 pi plus 6 pi. So that is 24 pi. If I choose to multiply that out by 3.14, replacing pi with 3.14, I should get about 75.4 inches squared. So the total surface area is 75.4 inches squared, and that would be your final answer, because it's still area. Alright, so the biggest thing here is looking at your formulas and making sure that you plug in your radius, square it when you have to, or if you're using circumference, you don't have to square it, and make sure you multiply by the height, and that all your parts are labeled, and that your pictures are nice and neat. Alright, I will see you guys tomorrow.